Hi, welcome to your 4-2 flipped video. 4-2 is called adding integers, so it's literally just how to add integers. We're not talking about subtraction, we're not talking about rational numbers, we're not talking about irrational numbers, we're just talking about how to add integers. So let's take a second and review. What's an integer? The integers are all the negative numbers, no fractions, no decimals, 0, and all the positive numbers. So the integers are all the whole numbers plus the negative numbers, and then the whole numbers are all the natural numbers plus 0. So it's all the negative numbers, all 0, and all the positive numbers, not including any decimals or fractions or any other weird things. So -2, -1, 0, 1, 2 goes up to positive infinity and down to negative infinity in both directions, okay? So any number like that is an integer, okay? So we're just talking about adding integers, and there's 4 categories of numbers that you could possibly category is the wrong word. Combinations. There's 4 combinations, all right? So we have a positive number and a positive number plus a negative number plus a positive number, and a negative number plus a negative number. These are the only 4 ways that you can add integers. There's no fifth or sixth or whatever extra ways. This is all the combinations. A number is either positive or negative, or 0. And there's only these combinations. There's nothing else you can do. Okay, so we'll look at each one of them in specifics. So let's start with positive and positive. Here's my number line. I'm going to do all of these in reference to the number line. I know that this might seem trivial, but we need to make sure that we have this skill, because once we start adding rational numbers, which aren't integers, you need to know how to do this. Okay, so a positive and positive, number line 0 to 25. Start off with an easy one, 15 plus 5. And I know you're thinking in your head, why do I have to use a number line? I know that's 20. It's so we can practice the skill. All right, so we're at 0. You always start at 0 in a problem. You always start with nothing. So what's the first thing that's given to you? 15. So you're going to move over to 15. So you moved 15 over to the right. All right, so now I'm at 15. So 15 plus 5. Well, plus 5 means I'm going to the right 5 more. All right, and now that's the end of the problem. So where's my dot? I'm at 20. So 15 plus 5 is 20. So we'll do one more really quick. 10 plus 20, I start off at 0. I move over to that 10 because that's the first number that's given to me. And now I have to add 20 more. So 10 move 20 to the right because it's plus 20 plus a positive number. I'm moving to the right. 10 plus 20 gets me to that 30 spot. So now I'm at 30. Problem's over. 10 plus 20 is 30. All right, so we're going to take the same idea and apply it to a positive number plus a negative number. So let's start with 5 plus -2. So you start at 0, and you move over to that 5, because 5 is the first number given to you. So now I'm at 5. Now I'm going to move 2 to the left, because I'm adding a -2. So negative numbers are to the left, positive numbers are to the right. So I'm moving over 2 to the left, because it's plus -2. So I'm at -3. Problem's over. Answer is -3. All right. You can also think as a positive number plus a negative number as a positive number minus a positive number. Okay? If that confused you, don't worry about it. Just keep thinking about it like this. Let's look at one more. 1 plus -4. So you start at 0. You're going to move over to that 1 spot. And now we're going to go 4 to the left because I'm subtracting -4. So 1, 2, 3, 4. There's my point. Problem's over. There's nothing else to do. So 1 plus -4 is -3. Okay? Now, if we start with a negative number and we go to a positive number, let's look at that example. So -4 plus +1, you start at 0, move over to -4. So I'm at -4 right now, and I need to move plus 1, and 1 is positive because there's no negative sign marking that it's negative, so you know in your head that's positive. If I told you 5, you wouldn't think, oh, that means -5. We assume in math if there's no negative symbol that it's positive. All right, so -4 plus +1, how do you go positive plus a positive? 1 to the right. So I'm at -3. All right, same thing again. -2 plus -3, you start at 0, and you move over to that -2 spot. So because it's negative, you're going to the left. And now you're going to add 3. So add 3 spots, 1, 2, 3. You're over at +1. All right, so negative 2 plus 3 is positive 1. A negative and a negative is another scenario that we have. It's the last one. Let's look at it quickly. So let's say you had negative 2 plus negative 3. What do? Well, you start at 0, move over to that negative 2. So negative numbers are to the left. So you're going to move 2 to the left. Now we're going to add negative 3. So again, negative numbers are to the left. So I'm going to move 3 more spots to the left. So negative 2 plus negative 3 is negative 5. One more. Negative 6 plus negative 2, same thing, start at 0. Negative 6 means go to the left 6, plus negative 2, you're adding a negative number, so you're still going to the left. 2 more to the left, so now you're at negative 8. And that's the end of the problem, okay? So just like how when I said if you take a positive number and add a negative number, you can think of that as a positive minus, that's a positive version of that negative number that's given to you. Just the same thing with negative numbers. If you were to pretend that these negatives don't exist and just say 6 plus 2, that gives you 8, and then you throw in the negatives back in, okay? So I don't want you to get tripped up by using tricks. The reason that works is because you're going all in the same direction. You're always moving to the left. So you're taking all your left components and putting them together, okay? If that is confusing to you, don't use it. Just stick with the number line. Okay, you will get better at this as time goes on. You'll find little patterns and tricks that help you remember this. For now, I would suggest using the number line and referencing your calculator. There's another tool we'll get to the other tool in a second. Let's talk about inverse property of addition really quick. So the inverse property of addition tells me two things. Every number has an additive inverse, and the sum of a number and its additive inverse is 0, and you'll remember that sum means addition. All right, so what does this look like? 6 plus negative 6. If you have $6 and you spend $6, how much money do you have? You have $0. Negative 11 plus 11. If you owe $11 to someone and you pay them $11, how much do you still owe them? You owe them $0. Okay, so you can take a number and add the opposite of that number. So in this case, 6 and negative 6 are opposites. 7 and negative 7 are opposites. A million and negative a million are opposites. So if you take the original positive number and the negative version of that number, also known as its opposite, and you add them together, the answer is always 0. So we can summarize this to say a plus negative a is 0, or you could flip-flop it, because addition, the order doesn't matter. Negative a plus positive a is equal to 0. Saying the same thing. You add a number to its opposite, you always get 0 regardless of what the numbers are, because they're opposites of each other. Okay, now let's talk about that last tool if you don't like number lines. We have integer chips. They look like this typically. We have the digital version on digits. I am not a fan of integer chips. I'll be straightforward with you. I think they're a great tool to help you learn it, but you get dependent on them, and then they're not really great for big numbers. You know, if you have a million plus negative 300, you don't want to put out a million chips and then take away 300 of them. It's not a good tool in that regard. So I am not a huge fan of integer chips. Let's look at a problem using a digital integer chip really quickly. So I'll do a simple one, 5 plus negative 3. And I'm sure in your head you're like, 5 plus negative 3, that's the same thing as 5 minus 3, so 2. Okay, so let's just practice. So integer chips, let's just say the yellows are positive numbers. So I have 5 positives, so I have 5 yellow chips, and then I have plus negative 3. So that's like 3 red chips, because each red chip is a negative 1. So because I have negative 3, and each chip means negative 1, negative 1, negative 1, negative 1, I have a grand total of negative 3. All right, I'm going to pair up the yellows and the reds, because then I have a plus 1 and a minus 1 for each one. And when you have a plus 1 and a minus 1, we just talked about additive inverses. Same number plus its opposite gives you 0, so they cancel each other out. So for those you science nerds, gravity or matter and antimatter. If you don't know what that is, don't worry about it. Maybe Google it. It's cool. So you do that for all the pairings, +1, -1, 0, +1, -1, 0. So what do you have left over? You have 2 yellow chips, which represents 2 positive ones, and 2 of them mean just 2. So 5 plus -3 is 2, which is the same conclusion we got to before. If you'd like to know more about integer chips and how you can use them, here's a video. And she also includes a little bit about blocks and stuff like that, but it's interesting if you want to visit it, okay? Let me know if you have any questions.